So now in continuation, let's do this question. Question number 5. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees. Okay. So let's suppose here AB is the original height, right? You can see here AB, this is the tree. Okay. This is the original height of the tree. And it got bent at a point C. Okay. It is broken here and now it is bent. And let the part C, right? Let the part CB is now taken this one, right? It is elevated like this. Okay. With it and making an angle 30 degree, right? That means, what does it mean? It makes the angle with the ground, that is 30 degree, right? So this angle is 30 degree here. Now the distance between the foot of the tree to the point where the top touches the ground is 9 meters, right? That means the foot of the tree is A and where it touches the top of the ground on the means this point B, which is touches here at point D, and this is 9 meter away, right? Now you have to find the total height of the tree. Okay, so these two things are given to you. Okay, so AB is the height of tree. Okay, right? AD is 9 meter, theta is 30 degree. Okay, means angle ADC is 30 degree, right? Okay, now as we have seen that this CB and CD is the same thing, right? So we can say CB and CD are same. CB and CD are equal, right? Is it clear? Now from the triangle DAC, right? This is the right angle triangle, right angled at A, right? Okay, so from right angle triangle DAC, what we have? Tan 30 degree means tan theta is equals to perpendicular upon base, right? Tan theta is perpendicular upon base, right? That is tan 30 degree is, now what is perpendicular here? Perpendicular is AC. This is your perpendicular, getting that? And base is AD, okay? Base is AD, so write down AC upon AD, getting that, right? Now what is tan 30 degree? Tan 30 degree is, can you tell me? What is tan 30 degree? Tan 30 degree is 1 by root 3, okay? Right? AC, we have to find, right? Okay, and AD is suppose, it is already given here, AD is already given, that is 9, okay? 9 meters. So in this way, we can say that AC is equals to 9 upon root 3, right? Now, if you rationalize this by multiplying root 3 with numerator and denominator, so it will become 9 root 3 upon 3, right? So this will cancel, this will become 3. So in this way, we have got the value of AC, that is 3 root 3, right? Okay, so this is 3 root 3 meters. This is the value of AC. Okay, means this portion, right? Now, again, from right triangle DAC, from right angle triangle DAC. Now this time, if we say the trigonometric ratio sec theta, right? So what is sec theta? Hypotenuse upon base, right? Hypotenuse upon base, that is.
Ma'am, or we can use the Pythagoras theorem.
Yeah, we will do that also, right? Okay, but we are solving here using trigonometric ratios, okay?
Okay.
So your hypotenuse is CD. CD is the hypotenuse, right? And base is AD, right? Okay. So now write down CD upon AD, right? Now theta is 30 degree. So sec 30 degree is equals to CD upon AD. Now what is CD? This we have to find, right? And AD is again 9. Okay. Now what is the value of sec 30 degree? Sec 30 degree is 2 by root 3. Okay. So these trigonometric ratio we should know. Sec 30 degree value is sec 30 degrees 2 root 2 by root 3. Okay. So we have put it the value here. Okay. CD upon 9. Okay. So now from here we can write CD is equals to 9 into 2 upon root 3. That is 18 upon root 3. Now rationalize the denominator by multiplying root 3 in the numerator and denominator. It will become 18 root 3 upon 3. Now you can cancel this. This goes for 6 times, right? And therefore we have got the value of CD, the length of CD, that is 6 root 3 meters. Is it clear? So in this way, we have got both the values AC and CB, right? So AC, we have got it earlier. This is AC, 3 root 3, right? Okay. That means AC we have got here 3 root 3. Okay. And CD we have got here, which is 6 root 3, right? Is that clear? Now CB and CD are same. Yes or no? Because this is the only part which is bending here, right? So CB and CD is same. So can we say that CB is also 6 root 3? Isn't it? Now to find the value, to find the height of AB, right, this tree, we can add both of them, right? 6 root 3 and 3 root 3. Is that clear? So now doing the same thing. So write down. So AC is 3 root 3 meter. Okay. CD is 6 root 3 meter, right? Okay. And this is equal to CB, right? Now AB is equals to CB plus AB, AC plus CB, right? Okay. AB is equal to AC plus CB. Okay. AC is 3 root 3 and CB is 6 root 3. Now we can add both of them. So it will become 6 plus 3, that is 9. Okay. You can take root 3 common. So it will become 3 plus 6, right? So this is 9 root 3. Now you can put the value of root 3 here to find the value exactly in decimals, right? The root 3 is 1.732. Now putting the value, AB is equal to 9 into 1.732. Okay. That is equal to around 15.57 meters, right? So in this way, we have got the value of AB. That means the total height of the tree was 15.57 meters. And this is the answer. Okay. So I hope you're getting this. Yes or no? Right? How to find the height of the tree, right? Okay. So in this way, we have got the height of the tree using the trigonometric ratios. Is that clear? Yes or no? Please note down. Look at the question. Question number 6. A statue 1.6 meter tall stands on the top of a pedestal, right? Okay. So suppose statue is BC, right? BC is the length of the statue, right? And it is given here, the length of the statue is 1.6 meters. Okay. So BC is 1.6 meters. And it stands on the top of a pedestal. So we can say that AB here is the pedestal. Okay. Now from a point on the ground, the angle of elevation of the top of the statue is 60 degrees, right? So let's assume that point on the ground is suppose O, right? And the angle of elevation from O to C, right? C is the top of the statue, is 60 degrees. So you can see here, this is 60 degrees, right? Angle of elevation of the top of the statue is 60 degrees. And from the same point, the angle of elevation at the top of the pedestal is 45 degrees. Means from the same point O, the top of the pedestal. What is the top of the pedestal? B is the top of the pedestal. And the angle of elevation to this top of the pedestal is 45 degrees, right? Okay. So this is given here. Now what we have to find? We have to find height of the pedestal. That means what we have to find? This height, h. Okay, we have to find the height of the pedestal. Just a second. Okay, is that clear? So here, what we have, BC is the statue. Okay, height of a statue is BC. That is 1.6 meters. Okay, right? And now we have to find AB. Okay, we have to find AB. So AB is AC minus BC. Hearing that? Okay, we have AB is AC minus BC. Hearing that? Okay. Now, if you can see here, since angles are already given, right? Okay. Now you can see here, this is a right angle triangle, right angle at A, right? Okay, so write down in right angle triangle OAC, okay, tan 45 degree, okay, tan 45 degree. You can take it as not OAC, right angle triangle OAB, yes. Tan 45 degree is perpendicular upon base, right? Okay, perpendicular is AB and base is AO, right? AB upon AO, getting that? Okay, tan 45 degree value is 1. Okay, tan 45 is 1. Okay, and this is equal to AB upon AO. So from this, we can say that AB is equal to AO, right? And what is our AB? AB we have taken here as H, right? Okay, is that clear? Okay, so suppose this is H and this is X, getting it? So you can say that H is equals to X. Okay, so this is our equation number 1. Okay, now again in right angle triangle, the bigger one, that is OAC. Okay, in the bigger triangle, again tan 60 degree, tan theta, okay, is equals to perpendicular upon base, right? What is perpendicular here? Perpendicular is AC, right? AC is the perpendicular and base is OA, right? Is that clear? Perpendicular upon base, that is AC upon OA. Getting that? Now, what is the value of tan 60 degree? Tan 60 degree is root 3. Okay, tan 60 degree value is root 3. Getting it? And now what is AC? What is AC? AC is H plus 1.6, right? The length of total statue and the pedestal. This is H plus 1.6, right? Okay. So can I write it as H plus 1.6? This is AC. Okay. And OA is X. Isn't it? Is that clear? So that means root 3x or x root 3 is equals to H plus 1.6. Getting it? Okay. Now, what is x? X is equal to H from equation number 1, right? So write down from equation number 1, H is equal to X. So now putting this value here, so what it will become? X root 3 is equals to X plus 1.6. Getting it? Is it clear? So now from here, you can find the value of X, okay? Or you can put X in place of X, you can also put H because we have to find the value of H. So rather writing this, we can do it. H root 3 is equals to H plus 1.6, right? So now it will become H root 3 minus H is equal to 1.6. That is, if you take H common, it is root 3 minus 1 is equal to 1.6. So H will be equal to 1.6 upon root 3 minus 1. Okay, are you getting this? Okay, are you getting it? Now, find it. So 1.6 upon root 3 minus 1 is, you can put the value here. Root 3 minus 1, 1.732 minus 1. Okay. So what it will become? 0.732. Okay. That is, now divide. This is equals to 2.185 approximately. So what is the value of H? H is approximately 2.185 meters. Are you getting this? You can also find the value in root form, right? So H is equal to 1.6 upon root 3 minus 1. Okay, so now you can rationalize it by multiplying with the rationalizing factor root 3 plus 1, root 3 plus 1 in numerator and denominator, right? So this will become 1.6 into root 3 plus 1 upon, now this will become root 3 whole square minus 1 square, that is 3 minus 1. So 1.6 root 3 plus 1 upon 3 minus 1. 1.6 root 3 plus 1 upon 2. So that's how H will be equal to, now you can cancel this. It will become 0.8. So you will get H is equal to 0.8 root 3 plus 1 meters, right? Okay, so you can also write down in this way, or if you solve it, then again, you will find the value of H is 2.185. Both are correct.
Yes.
Is
Now
that
can
clear?
you roll a second one or third, tenth one also?
So this was your NCERT question. NCERT exercise 9.1, question number 8. Right? So we were discussing the same discussion, right? Okay. Now coming to the next question. Question number 7. Now look at this next question. Two pillars of equal heights. Okay. So we have taken here two pillars, AB and CD. These are the two pillars of equal heights. Stands on either side of a road. Okay. So suppose this is road. AC is the road, and they are standing on the either side of the road, which is 100-meter wide. So this road is 100-meter wide. Okay. So this is 100 meters. Now, at a point on the road between the pillars, right? Okay. So at the point, right? Suppose the point is O. Okay. So this is the point which we have taken between the road, between the pillars. The angle of elevation of the top of the pillars are 60° and 30°, right? So one is 60°, other is 30°, right? So suppose this is 30° and this is 60°, right? Okay. Since elevation is not same, that means this point is not in between, right? Okay. Now find the height of each pillar and position of the point on the road. That means you have to find the position of this point O and the heights of the pillars, right? Means the height of pillars AB and CD, right? So this is the question. Okay. So here CD and AB are two pillars. Okay. So now write down what is given. Okay. AB and CD are two pillars. Okay. So these are the two pillars. And suppose both are having the same height, that is h meters, okay, of height, h meters, right? Because both are of equal height, right? Now, the road, width of the road, this AC, the road is 100 meters. It is already given in the question, right? And suppose O is the point in between, right? And this point is suppose x meters. Suppose we have taken OA is x meter, and therefore OC will become 100 minus x meters, right? Because the total length is 100, so this will be 100 minus x, right? Now, angle of elevations we have taken here, angle AOB is 60°. You can see here, this is okay. Angle AOB is 60°, and angle COD, okay, is 30°. These are the angle of elevations, okay, at the top of the pillars from that point O. right? Now, as we can see here that AB is perpendicular over AC, right? And CD is also perpendicular over AC, right? That means both the triangles you can see here are right triangles, right? So now, from right triangle AOB, from the right triangle OAB, you can see here OAB, this one is 90 degree, right? This is also 90 degree. So from this right angle triangle OAB, we have tan 60 degree, means tan 30 tan theta, that is perpendicular upon base. The value of theta here is 60 degree. This is theta, right? So you can write down tan 60 degree is perpendicular upon base. What is perpendicular here? AB is perpendicular and AO is the base, right? So perpendicular is H and X is the base. So you can write down H upon X. Getting that? Okay. And now what is the value of tan 60 degree? That is root 3. Root 3 is H upon X. Okay. So from here we can say that H is equals to root 3x. Getting this? And suppose this is equation number 1, right? So we have found it out H in the form of X. Okay. Now consider the another right triangle. From right triangle OCD, right? Now this time we are considering this triangle OCD, right? Okay. Which is right triangle, right angled at C. Okay. Now again, in this triangle, tan theta is equals to perpendicular upon base, right? That is H upon 100 minus X, right? Getting that? So write down tan theta is perpendicular upon base. The value of theta is 30 degree. So tan 30 degree is perpendicular. Perpendicular is the H, pillar height, and the base, which is 100 minus X. Getting that? Okay. So tan theta is equals to H upon 100 minus X. Now what is the value of tan theta? Tan theta is 1 by root 3. So write down 1 by root 3 is equals to H upon 100 minus X. Getting it? Okay. So from here you can again find the value of H in terms of X. That is 100 minus X upon root 3. Okay. You can take this 100 minus X to that side. It will go in multiplication. Right? So H is equal to 100 minus X upon root 3. And this is suppose equation number 2. Getting that? Now, as we know that both the equation are of H, this is from here we are getting H is equal to root 3x, and from equation number 2 we are getting H is equal to 100 minus X upon root 3. So we can equate both of them, right? So write down equating the values of H from equation 1 and 2. So what we get? We can write down that root 3x is equal to 100 minus X upon root 3. Is that clear? Now you can take root 3 to that side. Okay. So it will become 3. Root 3 into root 3 is 3. 3x is equal to 100 minus x. Okay. So 3x plus x is equal to 100. That is 4x is equals to 100. And therefore x is equal to 100 by 4. That is 25. So what is the value of x? That is 25 meters. Is that clear? So in this way, we have got the value of x here. Means this point O is 25 meter away from A, in between A and C, right? So the value of x here is 25 we have got, right? And now we can find out the 100 minus x also. Is that clear? So, okay. And also we can put this value of putting x is equal to 25 in equation number 1, right? So what is equation number 1? H is equals to root 3 into x. So putting the value root 3 into 25, right? Okay. Now you can write down the value of root 3, which is 1.732 into 25. After multiplication, you will get 43.3 meters, right? So in this way, we have got the value of H. And what was H? What we have assumed? What is H? H is the height of the pillar, right? So we can say that height of each pillar, because both the pillars are of same height of each pillar is 43.3 meters, okay? And the point of observation, what is the point of observation? That is O, right? Is 25 meter away from the first pillar, or you can say from the pillar that was AB. Okay, is that clear? So if AB is the first pillar, you can assume it that it is 25 meter away from the first pillar in between A and C, and height of the pillars is 43.3 meters. Okay, so in this way we have got the height of the pillars and the point of observation, the
Now we
location of
can
the point of
find the
observation.
distance between OC also.